The second type of sequence and series that we're going to examine in this unit is the geometric sequence and series. And we'll find out that there's some similarities and some differences to how we determine additional terms in the sequence as opposed to the arithmetic sequence which we saw last time. So an example sequence, 3, 12, 48, 192, 768, generated by this fractal image above, the snowflake. And this is a geometric sequence. The way we can determine that is by looking at the ratio of one term to the previous term. And in a geometric sequence, that ratio will be constant. It's known as the common ratio, and for our purposes today, we're going to call it R. As an example, if we look at the number of sides in the snowflake that's being animated above, the common ratio is 4. The second term of the sequence is 12 divided by the first term, 3. 12 divided by 3 is 4. If I take the third term divided by the second, 48 over 12, that's 4. And on down the line we go. So you can sample a couple. Go ahead and we'll work through the first one together, and then you can try the second and check your work. So I'm going to look at the second term divided by the first one, 16 divided by 32, and when I simplify that ratio, I get 1/2. I take the third term divided by the second, 8 divided by 16, and when I simplify that, 1/2. 4 divided by 8, 1/2, and 2 divided by 4, 1/2. So our common ratio is 1/2, and that tells us that, yes, this is geometric. Now, go ahead and pause the video and try number 2, determine if it is geometric or not, and then you can check your. So if you take a look, we divide the second term by the first, 2 over 1 equal to 2. Third term divided by the second, 6 divided by 2 makes 3. 24 over 6 is 4, and 120 over 24 is 5, so obviously the ratio is not common. Therefore, not a geometric sequence. Similar to our arithmetic sequences, we can write rules for geometric sequences. And the rule for the nth term of a geometric sequence looks like this. So a sub n, the nth term, is equal to the first term, a sub 1, times the ratio raised to a power, and that power is going to be 1 less than the number of the term. So as we look at the example sequence we had previously, 32, 16, 8, 4, and 2, and we're asked to find a sub 8, the 8th term. So we're told that this is a geometric sequence, which means that right off the bat we can divide the second term by the first and get our common ratio. So 16 over 32 is 1/2, and so now we write our general rule. So a sub n equals a sub 1 times r to the n minus 1. We substitute in 32 in place of a sub 1 and 1/2 in place of the ratio. So now we have our general rule. A sub n equals 32 times 1/2 to the n minus 1. You'll recall in class last time we were talking about order of operations. So every time that we do geometric sequence, we're going to see a multiplication and an exponent. We've got to simplify the exponent first. So the 8th term, so 8 is n, 8 minus 1 is 7. We're going to raise 1/2 to the 7th power, so that's 1 over 128. Now we can multiply by 32, and we get 1/4 for that value of the 8th term. So your turn now. Go ahead and use that example to try and write a rule for the nth term of each geometric sequence. You can pause the video. We'll come back and take a look at these together. Okay, let's look at our work together. So writing a rule for the nth term of the sequence. So given the sequence 5, 20, 80, and 320, I go ahead and first figure out my common ratio. I'm told that it's geometric, so 20 divided by 5 will give me the ratio. 20 divided by 5 is 4. So now I can write my general form, a sub n equals a sub 1 times r to the n minus 1. Substituting in what I know, my a sub 1 is 5, my common ratio is 4, and I'm raising that to the n minus 1. Careful now to not multiply these two together. I need to raise 4 to whatever power I'm looking for first, then I can multiply that answer by 5. So this is my rule for the nth term. 4, they put a little twist on it. They give us a term, a to the 4, a sub 4, and they tell us the ratio, and we're asked to work backwards from there. So let's plug this into what we know. A sub 4 is equal to a sub 1 times the ratio to n minus 1. So a sub 4 is 32. A sub 1 we don't know. The ratio we're told is 2. And since this is a sub 4, n minus 1 gives us 3. So 2 to the third power is 8. Now I'm going to isolate a sub 1. Divide by 8 on both sides, and I find out that our first term, a sub 1, is 4. Great. Now I can write my general form. A sub n equals 4 times 2 to the n minus 1 power. Just as we had arithmetic sequences and arithmetic series, we have geometric sequences and geometric series, and these we're going to add together. Well, as you can imagine, because we have a common ratio, sometimes adding these can get a little bit tricky. So similar to our arithmetic series, it's going to help a lot if we rely on the formula that we're given. So the sum of the first n terms of the geometric series is given by s sub n, and it's found by this formula, when the common ratio is r. So the sum of the terms is a sub 1 times this fraction, 1 minus r to the n power divided by 1 minus r. It goes without saying you're going to want to have a calculator on hand for these problems. So let's take a look at the first example. Series 3, 9, 27, 81. We're told that it's geometric, so we know we can go ahead and divide second term by the first to get our common ratio. So our ratio is 3. So now let's plug in what we know. The sum of the first 4 terms is a sub 1 times this fraction. So the sum of the first 4 terms, the sum of the first 10 terms is a sub 1, the first term, times 1 minus the ratio, 3 to the n power, that's 3 to the 10th, over 1 minus the ratio, 3. So let's see what's going to happen here. Let's try and simplify things a little bit. So in the denominator, I have 2. So 3 halves times 1 minus a really, really big negative number. How big a really negative number? This big. 59048 times 3 divided by negative 2 is going to give me 88,572. You go ahead and try the second one on your own. Pause the video. Come back to check your answer. All right, so no doubt the second one was a lot more challenging. So 10 divided by 20 will give us our ratio. That's 1/2. So the sum of the first 10 numbers is 20 times, and then let's plug in our values. 1 minus 1/2 to the 10th over 1 minus 1/2. Well, 1 over 1/2 to the 10th, that's 1 over 2 to the 10th, that's 1 over 10/24. So we're taking 1 minus a really tiny fraction in the numerator, and then the denominator is 1/2. So dividing by 1/2 is like multiplying by 2. So I'm going to go ahead and call this 40 times, and then 1 minus 1 over 1024. Okay, that's 1024 over 1024 minus 1 over 1024. So 1023 over 1024. And you can see that's going to be really, really close to 1. So if I multiply this out, I get 39.96. So a little challenging, some strange numbers to work with, but stick with it and you'll be able to nail this down. So be sure to take some time to summarize your learning for today. 3 things that you learned today, 2 things you want to know more about, and 1 big question that you still have.